Now there are two type of KTs. One is called gross stress concentration factor, another net stress concentration factor, depending on the what stress you are taking, whether the gross stress or net stress. If you have you seen the gas cylinder, you would have used day to day, right? Gas cylinder, have you noticed that a weight is mentioned? There are two weights. Yes or no? What is that? Yeah, correct. Yeah, correct. So even if the Tetra Pak you see, or packed food or tin food, there will be always mention a net, that the content inside that. Okay. So here also gross and net depending the things. When there is a no discontinuity, gross will be what? B in this figure, B is the width, T is the thickness. So gross stress will be B into T. But once you discontinuity in the form of circular hole or double notch, so what will be the area? What will be net area? Correct. So there will be always definition with the sigma maximum, sigma gross stress, and also sigma max by sigma net. Okay. If you see Peterson handbook, you people have referred Peterson. So any thing usually they will be giving kg, gross as well as net. But when you refer to SN curve and all, it will be always given as a S max net and all. So depending on what problem, especially when you are talking about stress concentration and all, usually it should be considered as a KTN, not KTG. Okay. And this is equation is same as the formula is given. See, there is another practical thing which people overlook. Always you take a kg. Of course, why it doesn't matter is because you are taking as a higher side. Actual the stress concentration due to net will be less compared to KT, but you are taking KTG higher value, calculating, and it is able to meet the objective. So you don't bother about whether you are taking correct KT, it should be KTG or KTN. Okay, so that is why people overload, but that is the difference of that. You have to be very careful when you do it, because that become very crucial when there is a situation will come where you have to mitigate on a problem. You have to mitigate the problem because your KT is happened, it's not meeting a fatigue life, or KT is too high. Then one way is you have to redesign it, or you have to look into any conservatism. So in that case you can do that way. So there is some generic information. See, when plate with circular is independent of dimensions, right? But when it comes to any other discontinuity other than circular hole, in this case in elliptical thing where it is minor axis of 2a and major axis 2a and minor axis 2b with r is radius of curvature, your KT is given same formula, sigma peak was sigma nominal, but it is 1 plus 2a by ab in terms of half major axis, half minor axis, or 1 plus 2 square root of half major axis and radius of curvature r. So it is dependent on geometry, your KT. So for circular hole, if when 2a is equal to 2b, you will get cancel, you will get 3. This formula holds good. A equal to b, so it will become 2 plus 1, 3. But in anisotropic material, example composites can be very sensitive for notches. Even if you take same plate with circular hole with become 3 as a benchmark, if you made a composite things material of the same thickness, same width and all, but KT will be very high. Sensitive means what? Okay, I told the answer. It will be high or low or equal. People have worked on composite. So generally, what do you expect? What should be the KT? You imagine two plate, one made of aluminum and metallic material, and is a composite with same width, with thickness, and same load as is given. What would be the circular hole only? D by W ratio is M. So what do you get? sensitive to notches. So what do you expect? You would have a more or less or equal? Why? Obviously, your metal is homogeneous. You have to do things, but in composite, you make a discontinuous as a whole. Your the cut is a no. They act as a potential local stress raisers. Okay, even though to minimize that, you cover it with adhesive, no close. Imagine you composite plate, you make a water jet cut. Nobody uses drill bit. Okay, water jet cut you have to do. Still then, if you use drill bit, is the worst case. A lot of fragment will be there, the fiber and all. So that it's a local stress. It raises the local stresses. Ket is more means local stress is very high. To reduce that, use a water jet. But unless you close that surface, still there will be cut cases, right? So that's at high.